Hi all, welcome to EduTech AI Prime. So today we are dealing with some important questions based on KTU BTech Maths S1 2024 scheme based on the subject code GAMAT101. So move on to the first question. Find the inverse of the matrix using adjoint method. A is equal to matrix 2 5 1 3. Step 1, we can find the determinant of A is equal to 2 into 3 minus 1 into 5 is equal to 6 minus 5 is equal to 1. Step 2, adjoint of the matrix. Adjoint of A is equal to 3 minus 5 minus 1, 2. Then we can find the inverse of the matrix. A inverse equal to 1 by determinant of A into adjoint of A. So we can get the same answer as adjoint of A. So we can move on to the next question. Find the rank of the matrix using elementary operations. A is equal to 1, 2, 1, 2, 4, 2, 3, 7, 3. R2 is equal to R2 minus 2R1. R3 is equal to R3 minus R1. So we can get the answer 1, 0, 0, 2, 0, 0, 3, 1, 0. The non-zero rows are 2. So the rank of A is equal to 2. So we can move on to the third question. Find the determinant of the matrix. A is equal to matrix 2, 1, 3, 4. Determinant of A is equal to, just multiply the diagonals, 2 into 4 minus 3 into 1. So we can get the answer is equal to 5. So we can move to the fourth question. Find the transpose of the matrix. A is equal to matrix 1, 2, 4, 5, 7, 8. Just reverse the matrix, rows into columns and columns into rows. So we can get the answer. A transpose is equal to 1, 4, 7, 2, 5, 8. So we can move on to the last question. Define diagonal matrix, identity matrix and zero matrix. Diagonal matrix. Non-zero elements only on main diagonal. Identity matrix. Diagonal matrix with all diagonal entries is equal to 1. Zero matrix. All elements are 0. Check consistency. X plus y plus z is equal to 3. 2x plus 3y plus 5z is equal to 7. 3x plus 4y plus 6z is equal to 8. Coefficient matrix rank is equal to 2. Augmented matrix rank is equal to 3 because the last row gives contradiction. The rank of A is not equal to rank of A by B because the system is inconsistent. So we can move on to the last question. Find eigenvalues of A is equal to matrix 2 1 1 2. We can take the characteristic equation modulus of A minus lambda I is equal to 0. 2 minus lambda the whole square is equal to 1. So we can solve this. We can get the lambda 1 is equal to 3 and lambda 2 is equal to 1. So we can move on to the next question. Find eigenvector corresponding to lambda is equal to 3 for A is equal to matrix 2 1 1 2. We can solve it by the equation A minus lambda I into x is equal to 0. Here A minus 3I into x is equal to 0. So the matrix minus 1 1 1 minus 1 into x into y is equal to 0. So the equation is minus x plus y is equal to 0. So y is equal to x. So the eigenvector is 1 1. So we can move on to the next question. N is a matrix diagonizable. A matrix A is diagonizable if it has n linearly independent eigenvectors. The algebraic multiplicity is equal to geometric multiplicity for each eigenvector. If eigenvalues are distinct, always diagonizable. So we can move on to the next question. State the rank nullity theorem. For an m into n matrix A is equal to rank of A plus nullity of A is equal to n. So let's conclude our video. We can continue our next parts on the next videos. Stay tuned. It's me Akshay. Goodbye.